Good afternoon. It's January 23rd and batteries are low. It is one of those days where focus, we're making nothing. 18 watts. Whoopee. 18 watts from the solar. 0 watts from wind. Rectifiers are nice and cold. I never explained what this is. That is a 300 amp solid state rectifier mounted to a nice heavy duty large cool heatsink, aluminum heatsink, and then a cooling fan behind it. All these cooling fans, there's 4-inch holes cut behind through this wood so it can just vent towards the concrete wall. I've got 1.5-inch spacers behind there, so it pulls air through those rectifiers real nice, keeps it nice and cool. Anyhow, back to this. So that's a 3-phase rectifier. Nice heavy wire on it. I got 4 gauge on it. That runs to a little project of mine. That is not a turbine. And if it was, it wouldn't be doing nothing. It's not doing anything yet. But yeah, we got no wind and no sun. It's a foggy winter day. So let's go outside and I'll give you a closer look at what that runs to. Alright, and we're outside. My control board setup is right inside of there. This is a box I made to house. This is my generator. This is my battery charger. When there's no sun, there's no wind, and there's nothing in the forecast but a whole bunch of gray. Panels over there. I'll get into that in another video. There's enough solar videos out there, but I'll highlight mine someday. On a nice sunny day, which I don't get a lot of in the winter. So we'll talk about this today. See there? Looks like just a standard Delco automotive alternator. It does share the case and I guess the shaft and bearings as a Delco. There's a little bit different fan on this. This came from Thermodyne. And this is their largest PMA, permanent magnet alternator. This is the dual core. Perhaps there's a larger one. I forget, there's a super core or a mega core or whatever the hell. This one very much so suits my needs. It's capable of 2700 watts. I've only personally tested it up to 24 just because it says right in the book not to exceed unless you're moving massive amounts of air through it to keep it cool. It can do more, but you don't want to overheat it, and I don't want to overheat it. It wasn't cheap, so I fabbed up a steel frame out of some square channel and different odd shit laying around the house, and I've got 7-inch radiator fans, one blowing into the engine and one blowing right into the back of the PMA. It's got nice big air vent holes through there, and that's the way these fans work. They pull the air from the back and out. So I just helped it out and that helps you know, pump a little bit of extra cold air into it. And the only time I really ever need this is in the winter time anyway, so I definitely don't worry about it overheating. And that's got a nice heavy cable coming out of it from the factory, and you can tell right here, you know, this is not a standard alternator. You know, this core, if this cover wasn't on and I had this out, you can see the magnet goes from here to here. This is all winding inside of here. The stator is enormous, and it's thick wire. I actually talked to one of the representatives at Thermodyne, you know, and asked him why there's such a price difference with the dual core as any of the other, you know, Hornet PMAs, and it's because the wire that they use is so thick that it has to be wound by hand, and it takes one of their employees an 8-hour shift just to wind a stator. And then of course, you know, there's the case assembly and everything else, and tightening and bearings, and line it up all real nice and run the wires out, and that's all layered up real good, and you know, vibration proofed and weatherproofed, and there's a real heavy duty varnish on the whole system, so it's very weatherproof. You know, these are actually made for wind turbines, but I use it for when my turbines are doing nothing. You can take a peek around this here big tree, that monster obstruction. And there she is. The other one's doing the same. Nothing. I did put the six blade set on today, so I'm kind of excited to see when the wind does blow how differently that works than the other blade set. But well, back to this. Just a out of the box Predator Harbor Freight 212cc engine. I modified the exhaust a little bit. I stripped the original muffler right off, put an elbow, welded that on, and ran the exhaust out of the box, and then that's a Stanley truck muffler, and then I choked it down just a little bit. It's quiet enough. It's, you know, I don't think my neighbors can hear it. It's a lot quieter than the engine was from the factory, and it gets all that heat out of the box. So between that and the two fans that are blowing in, and then they vent out of those holes, which have nice little vent covers to try and keep as much snow out as possible. The cool side effect of that is the exhaust blows out here, and that slowly melts the snow on the front, and these vent out on the sides, and that slowly vents, you know, melts the snow on the sides, and the heat slowly absorbs through the top, which I kind of soundproofed a little bit. So it kind of, you know, if it was in the middle of a snowstorm, it keeps the snow off pretty good. I just refueled her. I ran the throttle cable inside, and the fan switch is inside. And excuse the vibration for 5 seconds here. I'm going to pull on it and start it. That's all there is to it. I fill it up and choke it, pull it, close the box, and we'll go downstairs. There's that. Alright, we're back downstairs. So, at absolute idle, come on, focus, it's making 0 watts. I've got my throttle fixed right here, and fan switch, which I will put a temperature control sensor and automate everything, but that controls the fan for the rectifier. and it kicks on the 2 fans outside to keep the box warm. But let's just observe here as I start to throttle up. That's just a tiny little bit of throttle. 200 watts, about 10 amps. 5, 6, 700 watts, about 30 amps. Again, this is still just a little bit of throttle. Keep going. 1,000 watts, 1,050, 40 amps. See the volts start to climb. And usually I'll run her at 1,000 watts for about an hour, and I'll let the batteries just begin to warm up, and then I'll get my volts up to about 27.5 or so, and then I'll throttle her up a little bit more, usually to about 1,400 watts or so, 1,500 watts. And then I'll run it at this 1,400 watts until it gets me up to about 30.5, and then I'll hold her, I'll throttle it back down and hold her at 30 volts, 30.5 for about an hour, and I'll let it, soak and do bulk absorption, and after an hour I'll throttle it back down to 700 or so, and then I'll just to whatever it needs to go down to as far as input goes, but I'll bring the volts back down to about 27.6 I try to get it at, and then I let it float for another hour, and then I'll kill the engine, and that's a pretty darn good charge, and that burns up about a half gallon of fuel, and that gives me about 2 days of conservative power. If the forecast is crap, we won't run the laundry machine or the dishwasher, but I still got my fridge and my deep freezer plugged in. I'll try to refrain from welding, but just for fun, let's crank this thing up a little bit. You watched the video, let's watch it make some power, huh? That's about as I want to bring her, but let's see, 2,340 watts is 83 amps. This is with a 24 volt system. So you guys out there with 12 volt systems, do that quick math. 160 amps. Can you imagine 160 amps going into your batteries? This will get my batteries full fast. And if I don't watch it, it'll get them full too fast, where they'll bubble, and not just bubble, but they'll foam. I did that accidentally once, and I had to open all 60 caps back up and top them off, because lost quite a bit of liquid that day. But we'll go back down to about 1,400, and we're just gonna run her until my volts go up to about 30.5, and slowly work myself back down, and I'll kill her. But the engine itself, I put a 3.5 inch pulley on, and the alternator comes with a 3 inch pulley. And I experimented around with a couple different variations. I put a 5-inch on the alternator, and tried different ones on the engine, and I'm pretty happy with the ratio that I have now, which is it ends up being 0.89 to 1 engine to alternator. So the alternator is spinning about 11% faster than the engine, and I've got the governor set to not exceed 2300 RPMs, so the engine or the alternator never exceeds 2500 RPMs, and it works out really well, because at max throttle it never goes over what the factory says is safe. Come on, focus, focus. Focus, focus. Bring her back up, and then if we bring her back down, we can get that to 0 out. And I can control it pretty much all the way down to 200, 150, if I went the tiniest little bit down. Oh, yeah, 60 and 0. So at this pulley ratio, I've got the complete power band of this PMA, and I like that a lot. It doesn't load the engine down. It's not working real hard at all, and I get the power I want out of it to safely charge my batteries and to safely fill them up. Nothing else worked. I used to run a normal generator, just an off-the-shelf generator, to a battery charger. 25 amp, and that worked. It put power into the batteries, but when I went up to a 24 volt system, it did me absolutely zero good. And there's not a lot of options unless you want to spend really a lot of money on a 24 volt battery charger. And then to run that, I would have had to upgrade my AC generator. So there's just so much loss, and making AC to turn it into DC, turn it back into AC is just ridiculous. So this works pretty fantastic, and I can put real amps into my battery, because it's not the volts, it's the amps. That's the only way to fill them up. And if you're not filling them up on a regular basis, you're damaging them. And that's $2,500 in batteries sitting there, more than that. So and then the copper to hook them all together. Half the cost of my system is in damn copper, getting out to my turbines. There's 400 feet of heavy gauge copper running through my yard, and then coming back down here, and all this, the 00. The cost of the panels and the cost of everything else is one thing, but having somewhere to store it, and getting that power through the lines effectively, you got to invest in good batteries, you got to pile up enough of them, and you got to have good wire. And if you're not, if you're hooking it up with a bunch of cheap chintzy wire with shitty connections, I solder all my connections, crimp them all tight, and then crank them down tight on a bus bar and monitor everything. I can monitor the input going into my inverter, the output coming out of my inverter, so I can calculate my loss there. I can monitor every part of my solar system. Making nothing. Look at that, 14 watts. in every part of my wind system. You know, it's important. So yeah, this is just you know, and the expense that went into this is a little over 600, you know. So, but in the long run, I'm saving money, burning out generator after generator, burning out charger after charger. Being off the grid now for 3 years, I burned out a pile of all of it. And now finally I've got some decent equipment hooked up, and it's all hooked up right, finally. And you know, power's not a problem. If I gotta put a half gallon of gas in the old Jenny and run it once a week, that's not a big deal for me. So anyways, I hope you liked it. Take care.